And we are beginning today using the Path Design Workbench. Your instructor, as usual, is Fakinlede. So we have a lot on the menu today. We are going to send you a corrected slide system, a slide with the videos and the homework and everything will be given to you after the lecture. I've had so many errors, so I want to teach first. When I finish teaching, then I will see whatever errors also arises during the class. Please draw attention to errors in the chat. I will appreciate it, so that by the time I'm sending the corrected video, all the errors that you have noted would have been taken care of. So we are going to the Path Design Workbench, as I said. The recommended software for this course is FreeCAD modeling software for origination of the graphics that we shall use. I talk of origination because this class is not just about drawing. It's about design and about modeling. The issues about the design, most of them will not be known to you until you reach your final year. But if you already know how to use the tools, even before you learn the theories, you are far ahead of people who don't know how to use tools. And as the theories are coming in, you'll be able to practice and achieve things even while you are an undergraduate. So I personally use two versions of FreeCAD. I use the version 1.0.2, which is the stable version that I recommended for you. I also use the FreeCAD 1.1, the release candidate one. This version is not yet certified because I am interested in contributing to the development of the software. I want to help them do some crash testing so that I can report errors. If you have the time, you can do the same yourself. I have already noted some glitches, even though it is nicer and sometimes quite a tempting version to use. I worked double during this week because sometimes many of the things I'm giving to you today, I did in version 1.1. But after a while, I saw that the crashes were just too many. And it is better for you to do something that you are sure of than to do something that you never really know, whether it is you that you are making a mistake or the computer itself is not getting it right. But if you have enough disk space and a sufficiently powerful computer, you may install both versions without one conflicting with the other. As I told you before, FreeCAD is free and open source. Unlike retail software that you pay for, such as Autodesk Fusion, Inventor, AutoCAD, SolidWorks, Siemens Solid Edge, and other things like that, FreeCAD is actually FreeCAD because it is free. Free means you will not be asked by anybody to pay for the software. You need no license and you can install it locally on your computer, and there is no need to go back to any website unless you want more stuff. So that is a far cry from Autodesk and the people that expect you to stay online. You may not have the credits to stay online. So there are just too many good reasons why poor countries like ours should choose, who are interested in getting rich, should choose to go through this route and become very productive and then become rich. Open source means the code is not even hidden. So if you know C++ and how to program seriously, you can actually help them or help yourself and make your own version of it, and that is better than theirs. That's up to you. More than 300 programmers, testers, and documenters that have been involved and other volunteers place their work in the public domain, and you are therefore welcome to make contributions to it. That is an effort worth supporting because their product is really good. Now, we can take a look at the environment before we go on. In Windows, you can see a standard Windows page with menus and icons that ought to be familiar in any Windows software. The menus and icons below them vary with the current, with the changes, depending on what changes that there's a strong something there. It depends on the preferences you set. There are three areas of the screen that do not see much change through your modeling session: the object tree, the current workbench, the navigation panel, and the data panel. Many other things can be changed. These ones may not see a lot of changes, but even they can be changed. The object tree gives you a hierarchical order that signifies something close to a timeline of your drawing activities. Some things that can be changed to alter the creation timeline, as you will see. This contains specific activities that have been carried out. There is an eye preceding each item, and you can toggle to see or not to see. When you close that eye, you will see that that thing is no longer visible. When you open the eye, it can be seen. In the present setup as shown below, the data panel lies beneath the object tree. In some situations, you'll see the data panel lying on the right side of the page, depending on how big your screen is and depending on what settings you made. You are supplied with editable information on the current selected item. You can go into the data panel and make changes to the information it is giving you on the visible and currently active drawing element or drawing position. So you can get information, but the information you are getting can be edited. For instance, this is an example of something we will draw in this class. In this, you can see that the first red sign up here, which tells you path design, shows you the current workbench we are in. Other workbenches, when I fire up my own version, you will see the other workbenches you can use. But right now, the current workbench on this page is the path design. And then you have the object tree. Object tree shows you all the objects they might be in a compact form or expanded form. And this is what I mean by the eye. You can see the eye of the body is open here, but the eye of the origin is closed. So if you want to see the origin and the coordinate planes, you only need to toggle this by clicking on it, and it will show you other things, and that eye will be opened. Every other thing you see here can actually, there's an eye that is open or closed to anything. So anything you want to see, open the eye. And here is what I mean by the data tab. The data tab is here, and you can also move from data tab to the view tab, which gives you more information about the object you are viewing. And on top, like in any Windows system, you have your menu, file, edit, view, tools, macro, sketch, path design. This is changeable. And the reason why path design occurs in this menu is because we are in the path design workbench. If we are not in the path design workbench, there will be something else that will show here. So, and these are the icons. Normally, I don't bother changing these icons, but there are people who do. There are people who rearrange them. And it is up to you. If you are adventurous and you want to rearrange them for yourself, that is well and good, because it shows that you are inquisitive, and people who are inquisitive can learn a lot more than those who are not. I also want to draw your attention to the navigation theme at the bottom right corner there. On top of, below the date, which is current date, you see now that I have touchpad as my navigation theme. If you go in there, you'll see that you can choose between 8 to 10 different themes. The touchpad is very good, and it is a combination of keystrokes and keyboard, as well as the movements on the cursor plate that you have on your computer. All those things are there, and it's quite efficient. You can choose your own. If you like the touchpad, use it. If you don't like the touchpad, use whatever you like. There is nobody can catch you. So it's up to you. There are several workbenches to choose from. We can play around this and see their number. They vary depending on the number of add-ins you may have installed. At each occasion, what you do and can currently achieve is dictated by the chosen workbench. For those who are exiles like me from Fusion, the path workbench is what closely relates to the component creation mode you have in Fusion. Navigation themes can be set to resemble the graphic experience that you are most comfortable with. Right now, I use the touchpad theme. I want you to notice that if you allow your mouse cursor to loiter on the touchpad, what you will find there is that it will show you what results will come if you press the left button mouse, you press the right button mouse, you scroll the wheel, and so many things will be given to you as to what you can do. Sometimes it may be that you have to press shift before you move the mouse button. All those things will be shown to you if you just allow your mouse button and your mouse cursor to loiter around that area. And that's very useful. It doesn't matter if you are using the inventor, the same thing will happen. Whatever you use, you have that kind of experience. So this you select the theme you are most comfortable with. At the left of the screen, you see the view cube and the origin of coordinates. I'm sorry, that is not left. That is the right of the screen. So let me correct that because that's a grievous error there. The right side of the screen and the previous page, I didn't spell the word navigation correctly. Navigation. So I go back to my slideshow now, on the current slide. So at the right side of the screen, you see the view cube and the origin of the coordinate system. The view cube is close to the top, and the coordinate system for the global coordinates is close to the bottom. Again, you can go to the preferences section, which I will show you, and you can make those things bigger if you want them bigger. The size you are seeing now may not even be the size that it came with. On some of the computers I use, I have already increased them. If I have not increased them here, I will do so after some time. The global coordinates are always in view from that navigation system there, no matter workbench or sketching thing you are doing. It's a good idea to play around different areas to see how they behave. In subsequent classes, I will explain to you the difference between the global coordinates and the local coordinates. Keyboard shortcuts. There are many keyboard shortcuts that you will learn as you move on. For instance, 0 while you are in touchpad key will take you back home, but you can always get home by pressing the home key on your button. The home is the isometric, is usually said to be the isometric view that fills the screen with your current active drawing. And sometimes you want to quickly get there. So the way to get there is to use your home key. You can get there no matter what by pressing home on your keyboard. Setting preferences. If you go to the edit drop down, you will see several things there. This may not be consistent in many cases, but at the bottom of everything, you see preferences. The last thing at the drop down of the edit menu is the preferences setting, where you can rearrange most things on the windows and alter the way you navigate FreeCAD. It's good to make changes sparingly at the beginning. You don't know enough to know whether one way is better than another. So initially, you just allow that to be. It's a good thing to be sparing in your changes making. But if you are adventurous and you want to change, you can always return back to the factory setting. So there's no problem. There's nothing. Your computer will not get spoiled if you change many things. In part design, we start with the sketcher. The reason we start with the sketcher is that usually a part or a component, what Fusion 360 call component is what FreeCAD called part. So part and component are two words that I will use synonymously. To design a part, select a blank body and open the sketcher. These are the two left mode icons in the diagram above. You can loiter your mouse in any of the icons for it to reveal its purpose. The sketcher icon's hint is create sketch. Once you select that, the next thing that you are presented with the origin and 3 coordinate planes to choose from. The proper way to begin any sketch is to select the plane to which the sketch will be attached. You'll find later, as your design progresses, there are options to attach sketches to. You can use planes on objects already created or make datum planes for the purpose of creating new sketches. For instance, in today's, you can also do orthographic and other projections. using the tech draw workbench, and it will show you all sorts of views, and you can even decide to show their dimensioning. Well, I like it, but the dimensioning in the sketcher seems to be good enough. Sometimes it's much more, I find that one a little bit more amenable to changes and easier to use. So, but this is just another one, which is using the old engineering drawing perspective where you can take 3 views for the workshop. But now you can take as many views as you want. There is no need to restrict yourself to 3 views, but this is possible in the tech draw workbench. One view is isometric while the others are orthographic. Isometric tries to make a 3D drawing in 2 dimensions still in such a way that the distances are still preserved. That is what you call the isometric view. And that isometric view is what you have here. And then you have 3 orthogonal views. You can call one the front view, the top view, the right view, depending on whether you are using a first angle or third angle. All those ones are technical details that I'm not getting into here. The popular orthographic views are approximately 2D views from the top, the 2 side views. Many other views may be used. In modern 3D graphics, the number of available views is actually infinite. Now, this is the isometric solid body that we are going to draw first. And here is the solid model itself in its 3D view. We can set our camera direction at any orientation. Again, you have several alternatives here. Perspective with a vanishing point that gives a realistic result of what a human eye will likely see in real life. But it's not very good for taking measurements and for the purpose of our drawing. But I prefer the isometric view, which is easy to measure, but sometimes may appear unrealistic and artificial. As we already saw in the part design workbench has a sketcher tool for creating 2D sketches. Several tools exist that can create 3D solid bodies from these sketches. Some of these tools are additive, the rest are subtractive. Whether additive or subtractive, these create or modify bodies as you shall see. Our first task is to do fully constrained sketches, and that is not a trivial matter. As your lecturer, I can confess to you that I've practiced for several months before I got a good handle on how to come up with constrained sketches without under constraining or over constraining the sketches. And the goal here is to make sure that your journey is smoother than mine. That is the goal. So if it took me 4 months to get something done, it should take you a week or 2 to get the same thing done because you have me and I'm able to explain to you and show you how to avoid the pitfalls that are falling into so that you can concentrate on the things that I want you to learn. So the first task is not a trivial matter to do fully constrained sketches and then to get it right as quickly as possible. And the thing is that when you are applying constraints, you will need to gain skill to know where you should add new constraints. Because if you add the constraints in the wrong places, you are going to over constrain and it will not help you. Your drawing is as bad when it is over constrained as when it is under constraint. So you do not want your sketch to be under constraint or over constraint. When it is under constraint, you are told how many degrees of freedom you have, and your goal is to be reducing those degrees of freedom gradually until they become 0, and therefore you have fully constrained sketches. Once the sketches are correctly constrained, there's an error there. Please let me just correct that. Once the sketches are correctly constrained, it is relatively easy to get 3D models from them. You will see later that it is not every time you want to constrain your sketches. There are some times where you can just leave them. Sketches can be under constraint or over constraint. We want neither. It is desirable, as we shall see, that our sketches are fully constrained. It's often desirable. This is the first sketches we're going to be looking at. The one on the right is what we will start with. And you will see In the ones on the right, we only show three-dimensional distance constraints: the radius of the circle in, the radius of the diameter of the circle, the radius of the arc, and just one length. And with that, we have a fully constrained sketch. If you add any other constraint in addition to this, it will be over constrained, and FreeCAD is not going to be very happy with you at all. And you may get errors in the other things we want to achieve. So it is good for you to know how to just get the proper number of constraints. And you get the constraints, and when it is fully constrained, everything turns green, except the dimension annotations. It's only the dimension annotations. For instance, in this left-hand side drawing, everything is green, but where the dimension positions coincide with the thing, it will seem as if it's not everything that is green. Like you might think this place is not green, but it is green. It's just the dimensioning that is conflicting with it. But you will see in your drawing, when it is fully constrained, you will be told. So what we are going to do, I have 3 videos here. Don't mind that the videos you are sent, one of them is wrong. I've corrected that. We have 3 videos here. There is a reason why I prefer to give you videos rather than do the thing in class. When I do it in class, there are 2 problems. Number one, I am not as relaxed as when I'm doing it on my own free time. Number 2, the quality of Zoom production is lower than the quality that I can produce with the software I use. I use a powerful software that can do the origination properly and give you MP4 files. And when I compare that to what you get when I do it online, synchronously, I am not happy. I want you to have videos that you can use when we are not together, when you are on your own, that you can play back and rewind, and everything is clear. You don't get that from the synchronous display. Just like I told you in class that I don't, for this course, I don't think classroom teaching is the best. If you have the proper tools, which I do have, the online teaching can actually be superior. That's my opinion. But you are welcome to your own take on that. This is my last year anyway. So, and the only way I would ever teach in any university after now, because I'm not interested in coming to any class any longer, will be online. If I'm teaching anybody, the person will be ready to learn online. As for today's class, anything that I have put in an audio, in a video, I will attempt to do that in class by just going to FreeCAD and launching it and doing. So let us do the first one. So, but let me just see what I am saying from the students. No audio. Sir, how do we know the plane to start sketching on? What does constraint mean? Let me just see the questions so that I will answer them. The good thing is that we are going to do this thing in class now. No video since they're in PDF. We have seen the slide. We have seen it. Shared the screen first. And so, okay. So let me go to my own FreeCAD here. Let's go to FreeCAD. And we go through these things one by one. No, sir, press the share button. I've pressed the share button and it's still which share? New share or which share? Toby Sholade. Say I should press the share button. If I know where the share button is, I would have pressed it. So let's see what I've launched my FreeCAD. And now, so the first thing that I shared that you did not see, can everybody see my FreeCAD page? Is my FreeCAD page seen by the class? Is my FreeCAD page being seen by the class? Okay, so here now I'm going to do the same drawing all afresh, but at least I'm happy that I've sent you a curated a video clip that may be better than what Zoom will show you. But at least for this purpose of the class, let us go through it step by step. So the first thing is that you choose, you open a new document, and then after that, you click the sketcher. And if you loiter near the sketcher, it says create sketch. So that is what's going to happen there. So you click that and it says create, and immediately you are given 3 planes. Somebody has asked, how do I know which plane to use? Well, you are going to get that by experience. Many times it doesn't really matter. Just use one plane. But after some time, when you are combining different things to make a single part or component, it may be strategic the way you choose your sketching planes. But for the first one, it shouldn't matter too much. I'm going to start our own sketch here on the XY plane. So on the XY plane, you can see the way I'm choosing the XY plane. And once I choose the XY plane, the XY plane is given to me. And the first thing I'm going to do is to create a center circle of 20 units. So I click this and I come to the center circle. You know, by the time I get to the center circle, there is a cross that tells me I am at the center circle. I will not click anything until I get to that cross. If I click before that cross, even if it looks as if I am there, I'm going to have problems with constraining my drawings later on. So you do not, if you want to start from the center, if you are careful, you should be able to see a cross that shows I am at the center. So at that center, I'm going to choose 20 millimeters as my radius. And you can see immediately I have a fully constrained sketch, because you can see it is telling me it is fully constrained on this side, and it is showing me green because I am referring it to an absolute origin that is always known to FreeCAD. That origin is always known. If I take the center of the circle at the origin and I specify a radius or diameter, that is a fully constrained position. So that is 20 millimeters, as you can see here. That's 20 millimeters. So that is fully constrained. The next thing I'm going to do, I'm going to choose a polyline. In my polyline, I will start the polyline from somewhere here, and I deliberately do not allow it to be horizontal or anything because I want to deliberately put those sketches later on. But when I am, after I've reached the point, you can see that it's showing me there's a sign that shows that I am on this line. I will talk about that shortly. Now, here, I want an arc. I want an arc. There are several ways I can get this arc from the polyline, but the easiest way is to press M 3 times. If you press the letter M 3 times, 1, 2, 3. By the third time, you can see that it has given me an arc. So I want to arc around that. I want to arc around that circle, and I've arced around the circle, and it is telling me I still have my polyline, and it has noted that I am constrained to the vertical line. You can see, so that is the second point. And then, and you see in polyline, when you are coming out of an arc, it makes sure that the line that comes out of that arc is a tangent to that arc. So I can come here and I have my third point. And what I want to do next is to close it. To close it is easy because you will see that cross again that tells me I am at a point. So you can see this one. You can see what you have here. What you have here, I'm told that I have 5 degrees of freedom. And before I move on, let us just look at those 5 degrees of freedom. For instance, if I pick this point, you will see that I am not allowed to move this point away from that line. It can go up and down, but it cannot go anywhere else. This point also can go up and down. That's the second degree of freedom. And this one can go up, down, and left, right, up, and down. Those are 2 degrees of freedom. And then this one can go like this, like this. So that's another degree of freedom. So I want to start making my constraint. As I apply each constraint, I should be checking that the constraint is reducing my degrees of freedom. What I want to do first is to make sure that this line is vertical. I pick the line and pick the horizontal vertical constraint. You see, when you pick a line and you pick the horizontal vertical constraint, the line will become vertical if it is close to vertical, and it will be horizontal if it was close to horizontal. So the horizontal vertical constraint can constrain to vertical or horizontal depending on the circumstances. Similarly, I want this line to be horizontal vertical, so it is going to be horizontal. And this one, it is no longer necessary for me to put a constraint here. This is the trick. This is where one will get into trouble, because these two, because of the arc that I have here, these two are moving together. So since this one is horizontal, this one is automatically horizontal. If you now apply a horizontal constraint here, you are going to have an over-constraining situation. Now, the next thing I want to do is to get the radius constraint along this arc. So the radius constraint along the arc, I take the constraint radius tool there, and I choose this, and it's asking me what radius do I want. I want 20 there. So it is giving me a radius of 20, and then that is, okay, so it has given me a radius of 20 for that. And you can see there's a problem here now. It has moved, these two are not coincident. So let me see whether I can use coincident to force these 2 points together. If I can't, that's a very classical example of what causes problem. Okay, it has joined them. So it has made the center of this outer circle and the center of this inner circle to be the same. So you can see I have only 1 degree of freedom left. So the thing is, what can I still change? Okay, you can see this is the degree of freedom I have. I can change the length of this one. I cannot change the vertical length of this, but I can change the horizontal length of this. So I will I will do my last constraint by picking the dimension of this. And I'm going to make that dimension 20. So if I make that dimension 20, you can see that right now I have a fully constrained object. That fully constrained object is now ready for 3-dimensional modeling. So I can go and close. So once I close that, it is fully constrained and I can close it. And what I want to do with it, I want to create a pad, which is an extrusion. So if I create pad, immediately it gives me some default values. The default dimension is 10 millimeters thickness, which is good, but it did it to one side, but I want it to be symmetrical. So I just click symmetry, and that's all I want. It is symmetrical, and it has, if I close, if I say okay, that is okay, and that is done. And let us see what has happened to the object tree. Here in the object tree, you can see that the sketch has its eyes closed now. If I still want to see the sketch, I'll just need to open it, and I can see the sketch that created all of this in this place. So if I don't want to see the sketch, I will leave them like that. So the first side of it is done. So let us now go to the second side of it. The second side is going to be done with another sketch. This sketch is going to be at the perpendicular this direction to so the correct place is now the XZ plane. So this sketch is going to happen on the XZ plane. So on the XZ plane, and I'm going to do that sketch around here. One thing that is very useful is that before you start your sketch, it is a good idea to take some reference. You know that the original drawing was fully constrained. So if you take a reference to it, any reference to that fully constrained thing will continue to be fully constrained. So I want to create external geometry. This is the icon that creates external geometry. The external geometry I want to create now is the geometry that came with the past drawing. So create external geometry, and I come here. In my particular case, what I'm interested in is this edge there, that corner. I'm interested in this corner. So I've taken that corner. I'm not, for this particular drawing, I don't need any other thing apart from that corner. For example, I can start this by drawing a circle. I can draw a circle. I've not done anything about this circle. I just draw a circle somewhere. What I want to do with this circle is that I want the radius, the center of the circle to lie on this horizontal plane. So what I'm going to do is that would press Control key down, choose this point, and choose the point that came from the external geometry. So those two have been marked, and I'm going to use the horizontal vertical constraint on them. So with the horizontal vertical constraint on them, see what has happened here. This center can only move horizontally. It cannot go up, it cannot go down. And it is telling me that I have 2 degrees of freedom left. Now, let us see. Let us constrain the radius of the circle. Constrain radius. If I want to constrain the radius of this circle, I can come here and choose a radius of 10. So this circle has a radius of 10. So that's the radius of 10. Then I still have 1 degree of freedom left. I want to let us put the distance between this center and this point, and let us make that 20. So I'm going to say horizontal distance. The horizontal distance here from here to here is 20. And you can see immediately that I've specified all those things. You can see that the circle now is fully constrained. So I want to move this away so that you can see it. So that is all. Maybe let me move it below here. So this circle is fully constrained. The next thing I want to do is to create a polyline around that circle. I can begin the polyline, pick the polyline tool here, and take this and move up. Again, by experience, even when I want something to be horizontal vertical, I don't do it immediately. I just exercise some patience. So here again, I want to round it up at this point. I'm going to press M 3 times. 1, 2, 3. So the 3 pressing of M allows me to get an arc there, and I want the arc. Then after the arc, I move down some distance, and I'm going to press the M 3 times again, and then I have another arc here. So it is coming to this point. So I want to close it at where I started, and you can see that cross. So I've closed it, and I'm done with that. So what we have now is to apply our constraints. The first constraint I want to apply is that I want this line to be vertical. So I click it and choose the horizontal vertical constraint. So it is vertical. I also want this one to be vertical. I think, let's see, let's see if it is vertical. So that is vertical. And I want this to be horizontal. I want this also to be horizontal. So, okay, so it's a impossible constraint. So that is, it rejected that constraint. Let us see, which it didn't create trouble for me. So let us stop that. So what else do I want to do? I want the radii of these 2 arcs to be 10. So I will take a constraint on the radius, constraint radius here, and this, oh well, I don't know what's happening. Let me start again. Constraint radius of this, and I want it to be 10 millimeters. Okay, I want the same thing here to constrain the radius here. Or let me make this one. Okay, let's constrain the radius here to be 10 also. Okay, so let me move this drawing a little bit in here so that we can see everything. I want this line here to be vertical, so I choose the line and I click horizontal vertical. So that is there. How many degrees of freedom I have left? Have I left? So I have 3 degrees of freedom. It is still under constraint. So I want to choose the horizontal, I want to choose the width of this horizontally, and I want 40 for that. So I pick this point, I pick horizontal distance, pick this point and this point. The horizontal distance is 40 that I want. And then I also want the vertical distance to be 50. So for the vertical distance, I say I want to constrain vertical distance. I pick this distance from this point to this point, and I want that to be 50. So it tells me there is still 1 degree of freedom left. So let us find what that degree of freedom is. Uh, this is okay. This is none. Okay, let me try and get this dimension here. I want to constrain that dimension because there is nothing constraining that dimension. It can go up and down. So there's a movement possible without violating anything. So let's us take this dimension here and look here, dimension. I want this dimension to be 20. So you can see, I now again have the drawing is fully constrained and everything about it is green. So because of that, I'm able to close. I've closed the drawing. So I can now do a pad. I can choose a pad. So when I choose a pad, it's again setting the pad thickness at 10. This time I reject it. So I'm going to put 20. And then I want it to still be symmetric to the plane. So if I'm happy with that, I can click OK. All right. It is looking like what we want now, but we still can add other refinements. I can add fillets to several parts, but let me just add fillet to this point. If I fillet that point, it also has a 1 millimeter radius for the fillet. I don't like 1 millimeter radius for the fillet. I want 9. So that gives us the fillet there. I can see fillet. I can fillet under it too. I can rotate it in the touchpad. If I want to rotate, I hold down the shift key and the left mouse button, and if I do that, I'm able to rotate. So if I can rotate this, I can add the fillet to this downside too. So I can say, I can take my fillet tool and I can come here and choose this part, and I want a fillet of 9. Let me see again. Fillet here. I want to remove this. Delete. Well, there are many other refinements. I don't want to spend time on this. I want to leave this drawing now, and we can do more stuff on this drawing later. But I want to leave this drawing now and leave it at the present state of refinement. You can do more refinement on it on your own. And this is the first drawing that I was trying to. I've already done a video of this. So you will tell me whether you prefer. So you will have something to compare with. You compare the video I sent to you to the video I've just done in class. The same results have been achieved, but let me know which one is best for you, which one you can learn from, because you can also have a video of today's lecture in addition to whatever video I sent to you on the slides. So I can close this and discard this drawing because I've done this in so many times. So I can close all. I can close all now and discard the drawing. Don't need the drawing. So with that, we can now go back to our slide projection and go to the next slide and do our so it is not a bad idea to do a pencil sketch of the idea you have. I do not do this personally as I do all my rough stuff directly on the software. If you have sufficient experience and you are comfortable to do that, that's okay. However, you may waste a lot of time if you do not make wise choices as you start. Be sure you understand your navigation buttons, mouse and keyboard before you start. Rigid starting point, make the origin of global coordinates 000 is always known to FreeCAD. So mark that. So everything is eventually referred to that. Or you also have your coordinate lines and the coordinate planes. They are also known. So when you take your references from the coordinate point, the coordinate lines, and the coordinate plane, it is very easy to fully constrain your drawing. And then anytime a drawing is constrained, every point on it becomes a reference. If you make references to any point on it, that will also fully constrain other drawings. So that is how you build up your constrained drawings. And somebody asked me, what's a constraint? Constraint, there are several constraints. The location of the center of a circle is a constraint. The radius of that circle is a constraint. If the circle is tangential to something, it's a constraint. If a line is vertical or horizontal, that's a constraint. If the line is oriented at a particular angle, which you give. So there are several ways you can make constraints. Everything you do will be eventually referencing some known point. So that is how you create a fully constrained sketch. You can see here that it's after we constrained our sketch that we could do something with it. Now, simplicity is the watchword for an efficient and effective FreeCAD sketch. It is preferable to complete a simple issue in a sketch, use it, and move to the next issue in a new sketch. In Fusion, I used to have extremely complex sketches. That system is very tolerant of that behavior. But here, simplicity gets you a lot of mileage, and you'll be surprised what you can accomplish with simple sketches. Never assume you know anything because you understand how I did it. Oh, Fakinlede did it this way, so and I know what he did, I understand it. That's bullshit. That's not the work. It is when you do it, that's when you understand it. Anything you have not done, you don't understand. The only thing that matters is how you did it. If you had not done it yourself, in this course, you do not understand it. So it's only what you have done that you understand. And there is no reason to copy any other person. Don't have such a low opinion of yourself. There is nobody in this class that cannot learn what I am teaching. What I am teaching you, I can teach it to the SS1 child, and they will understand. And I've been doing that. I've been teaching children Python programming. I've also been teaching them graphics, and they have been understanding. You have you have better education than they do, and all you need is a sense of self-worth, that you know that you don't have to copy from somebody else. The person you are copying from, how many heads does he have? We are starting from scratch. Nobody in the class needs to know anything today. If you don't know anything, that's good. Start knowing something today. At least you can start your first drawing and just follow the example that have been given. Three things are critically important. The first one is practice. The second one is still practice. And the third one is practice. If you do not do these three things, you are going to fall behind. And you have to start today. If you have not already started, start today. This, you will see at the end of today's class that things are going to mount up very fast. We will start losing people in your set today. The people who are going to get F in this course, start collecting that F from today. And it's going to depend on whether they practice or not practice. It is not depending on the lecturer because the lecturer will do his best. It's not depending on the free card, the 300 people that worked on it, they have done their own part. And it is not your computer's fault because your father bought you a computer or you got a computer for yourself. It is because you have not been practicing. The most complex design is a sequence of simple ideas. You should be surprising yourself in 2 weeks of serious practice. In 2 weeks, when you are drawing, you'll be just say, is it me that I'm doing this? You'll be surprised and you'll be surprising yourself. And I told you the scope of how useful this coding in Python and learning how to draw will do for you. I am sure 5, 10 years down the road in your life, you'll be thanking me that I emphasize this for you because it is the make or break of your engineering training. Can you program? Can you draw? And can you bring those to bear in the theories of engineering that you are being given? So after the lazy ones start falling behind quickly, even from today, the lazy one will start falling. Will you be one of those lazy ones? If you want to be one of those lazy ones, you are welcome. If you want to be one of those people that will actually use this to improve their lives and make a difference and not be looking for a job, if you can program and you can draw, you can never be unemployed. It is not possible. After you have understood to do something, execute the idea in different ways. Like now, I have drawn this. I saw this particular drawing on the web, but the way I'm drawing it is not the way the person drew it. I didn't like the way he did it. I think I can do it in a much better way. I want you to have that attitude too. Each drawing I show you can be done in several ways. There are good ways to do a thing, and there are better ways to do the same thing. After you have seen better ways, seek the best. You are on your way to becoming an expert. There's an error of spelling there. So, master simple ideas. So, crude connecting rod. The next thing we're going to do is a crude connecting rod. We showed several possible connecting rods in the last lecture. Here we are drawing the simplest one. Draw two center arcs, connect their ends with straight lines, impose tangency conditions on 4 joints, add a number of dimensional constraints, and that gives you the simple connecting rod. The added video takes you through the full production. We edit the sketch one more time to improve the connecting rod and take away some materials as detailed later by the simulation. For today, I'm not going to depend on the videos I sent you. Every drawing that I show you, I will do the drawing right here. And then that will give you an opportunity to compare what I am doing synchronously with what I have done out of line and see which one is the better one. I want your comments so that we'll see which one to be using. So these are the 3 things we're going to do. We will do one arc, centered arc here, another centered arc here. We are going to join them crudely with straight lines. After we have joined them crudely with straight lines, we are going to impose tangency conditions at those 4 points. After we have imposed tangency conditions, we are going to give radial dimension conditions for the 2 radii and then the distance between them. Once we do that, this thing will all become grain, which will be fully constrained. So now, instead of going this way, I'm going to leave this now and go back to my free card and go to my free card. And in free card, I'm going to just go and start a new file. And in the new file, I start a sketch. I'm going to do the sketch. I like the white Z plane whenever is available. As I told you, the first thing is to do a centered arc. So we take the arc, we take the center at the origin, you make sure you see that cross, and then after you have seen it at the origin, we're going to do that there. So that is the first arc. So that arc, I'm going to move this thing down a little bit, and I can give it. I don't want to constrain it first. I want to do the second arc. The center should be along this line, and you should see that it is along the line. So I want it to be like this. Okay, so okay, the next thing I want to do is that I want to join the edges with straight line. So I take this line from here to this one and take this line from here to this. Okay. The next thing, I want to apply constraints to the circles. I want radius constraints. I want this one to be a radius of 16, whereas this one is a radius of, I want this one to be a radius of 36.5. Okay, some problem have arisen there. So I first of all want to remove this vertical constraint there. I don't want a vertical constraint. So delete. I'm deleting the constraint that it put. I didn't send it on that message. So I don't want that vertical constraint. So I want to put this one. I want it to be here. But I cannot trust my eyes that I've done it right. Or let's see. So what I'm going to do, I'm going to mark here. There are two endpoints there. I'm going to to make those points coincident. Okay, so let us make sure that, okay, so the points are coincident. So I've gotten out of the trouble that I entered just now. So you can see this is a radial constraint there. The radius is 36.5 and the radius here is 16 mm. So what I want to do now is to apply the tangency constraint at those points. So I'm going to take the tangency constraint. I want this and this to be tangential. It's giving a warning. Endpoint to endpoint tangency was applied. The coincident constraint was deleted. So that's what I want. I want tangency. Not it's more important. So say okay. Even though that warning is there, the warning is good. So the same thing, the warning will come again. So you say okay there, and then you take this one and this one with the warning again, okay there, and this one and this one with the warning again is okay there. So you can see here, let me make that a little bit bigger. So you can see here that so it tells me that I still have 1 degree of freedom. Don't rush to apply a constraint when you are told that it's a degree of freedom missing. What you need to do is to be gentle with yourself and be careful and see, okay, what is movable? Is this point movable? Yes, it is movable. This point is movable. And all of those, is this point movable? All of that, I don't like this. I've never been helped by these error messages. So let us see. So what I'm going to do, I'm going to take the distance between here and constrain it to 180. So I'm going to choose the vertical distance, and that vertical distance is coming from here to here. I didn't get it. So constrain vertical distance. It is no, cancel. I'm taking the distance from here, cancel. Vertical distance from here to here. That this vertical distance, I want it to be 180. And you can see that as soon as I constrain that, everything now becomes green. Everything has turned green. And so what do I have here? I have the constraint between this for the distance, for the radii, and then I have all my tangency rules, and everything is okay now. So one more thing we need to do is to do some pins for the piston and for the crankshaft. So those pins will be circles there. So I can do a circle here of radius 10, of radius 10. Oh no, radius 10 is not, it gave me a diameter 10. I want radius 10. So let me edit that. So the diameter is 10. So if it's radius 10, the diameter should be 20. So 20. So radius 10 or diameter 20, the same thing. Similarly, I want one of 50 radius at the center there. So I take a circle there, take it of 50 radius. So that's 50 radius. And I think this is pretty good. Everything is fully constrained. I close and then go home. So you can see everything there. I don't need, okay, the sketch is still there. So I can now do a padding. So the padding here gives us 10 as usual, but we want 20 this time. And then we want it to be symmetric. So you have now uh, a crude connecting rod. We can make this connecting rod a little bit better by going back home and removing some material as will become obvious when we do some simulation later on. We can remove some material from the middle to make it a little bit better. And to do that, we don't need to, we could do that by creating a new sketch and doing a hole or a pocket through the center there. But we can just go to the old drawing and edit that sketch. So if I right click and if I right click on the sketch and I say edit. So what I'm going to do, I'm going to do two arcs. I don't want circles, I want arcs. I want to do an arc centered here, and that arc will be like this. I want another arc below. So centered arc from this line. Okay. As before, I'm going to join the ends of those arcs with lines. Please don't rush. Make sure you see the cross that shows you are at that end. And then when you get here again, don't rush, see the arc. If you rush, you are going to pay. Okay. So right click to take that off. So the first thing is that I will do this. Let this be tangent here. Tangent, tangent. And then this is tangent, tangent. Okay. And this is tangent, tangent. Okay. And this is tangent, tangent. Okay. So if we're happy, the next thing we need to do is to constrain the radii of the two arcs. So constrain radius, constrain radius. I want to constrain the radius of this one. The radius is at 15 now. Let me make the radius 18. How does that look? And the radius of this is at 11. Let me make it 11 is okay. It tells me I have 2 degrees of freedom left. Let us see what is causing the degrees of freedom. one, I can move this up and down. I can move this up and down. So let me do something so that I will not be able to move this up and down. I want to take the vertical distance from this center to this to be 40. So I'm constraining the vertical distance. So I'm constraining the vertical distance from here to this place, and I want it to be, is it 40 or 60? I want it to be 60. 40 will be too small. Okay, so that is vertical distance of 60. I also want the vertical distance between here and the upper circle. So I take the constraint of the vertical distance from here to here is saying 34. What do I want? Let us make it 35. Okay, so you can see again, everything is fully constrained now. And what do we need to do? Nothing. All we need to do is to say, okay, our close, and you will see that our desire has been affected. You can see that because we did a proper sketch, it already knows, it's like a winch. It already knows what we wanted to do. And see what we have now. Okay, we have already gone 11 minutes past the middle of our class. It is my desire to always give you some break. Unfortunately, today I can't give you the 20 minutes I gave you yesterday. I'm going to give you 15 minutes break. So we'll get back at 11:27. We continue at 11:27. So, but please, admin, don't close it up. I want to spend time to check what they have written in the chat room so that I can address some of those things when they come back. And then, admin, again, when the lecture ends, please stay for at least 5 to 10 more minutes because I also want to go again over the chats that have arisen so I know what the students are thinking. So we meet again at 11:27 to finish this class. So the next drawing we are going to do is the 3D Mobius. This for this is a mathematical interest. The strip of paper you have there has only one side. The Mobius strip is a sheet of paper with only one side, and this has fascinated mathematicians for a long time. It is one-sided if you define a side as any part of the paper that can be reached without crossing the edge. You can reach every part of this paper without crossing an edge. The Mobius strip satisfies that, and it is the classical non-oriented surface of mathematics because there are more than one outwardly drawn normal at each point. What we are going to do now, we are going to create a solid figure that is inspired by the Mobius strip. And this is one of the sketches we will use. The other one is reversed, and it will be on another plane. The same drawings can be copied. I try to do the copy, but I still have not been able to copy it. So I do the drawing twice. So we will see how far we can do that here. This is the kind of result you are supposed to get at the end. And I think instead of, I have the video of it here. So you'll get the video, though I will update that by what I'll give you after this lecture. So let me just try and do that video before I give you the, let's go to FreeCAD now. And let's see how quickly I can do. Let me just start from something new. And I'm trying to do, where am I sketching now? Let me sketch on the XZ plane. So I sketch on the XZ plane. Here, as before, some people were asking, how do you move? Hold down the shift key, and then if you hold down the shift key and you just move your mouse, you will see that it is moving with you. And if you make it can make it smaller or bigger. So what I want to do now is to draw a circle. Oh, is it a circle? No, I would like to start my drawings with what is called a center arc. So I start the center arc here and do it here like this. That's the center arc. Let me constrain this to be how long now? Let it be 50 radius. So as to give me constrain the radius. Constrain the radius to be 50. And then let me go home and see how that one shows up. Okay, so the radius is 50 here. Okay, so the next thing I want to do is I want to do a horizontal, something that is like a horizontal line. I always like to deliberately not make my horizontal line horizontal because it is easier for me to apply my constraint directly. So from here, I first of all take a line from this end here, go down a little bit, and then press M. M 3 times. 1, 2, 3. Oh, no. That is wrong. So let me remove this. It is a polyline tool I want. I want a polyline tool. And then I start from this point here. I go down a little bit. And then I put M, 1, 2, 3. And the M, and then I join it here. And then I start again from here. Polyline. I do a line first. I press M 3 times. And then I join it here. So the first thing I want to do after that is to get the tangency done. This and this tangent, good. Okay, and this, there's a tangent there. Okay. Okay. I want this horizontal distance from here to here. I want a horizontal distance from here to here. I want the horizontal distance from here to here. Oh no, it's not working. What do I do? Okay, let me make this thing horizontal. Make this one horizontal. And then choose the dimension of that line. Dimension of this line. I want that dimension to be 20. Okay, so I want to place it here. And I want this one to come down here a little bit while I place this one here. I want this height to be 50. So the dimension of that height, I want this to be 50. I want this also. I want this and this to be on the same horizontal plane. It's trying to wreck what I'm trying to do. I will not let you wreck me. So let us go back. Let me first of all make this one horizontal. And then I want to choose this and this. I want them to be on the same horizontal plane. Okay. So well, now I want to choose the distance, the horizontal distance. I want to constrain the horizontal distance, constrain horizontal distance from here to here. I want that horizontal distance to be 10. So that is another way of getting what I want, which is that thing is, so if half of it is 10 and the full thing is 20, I've achieved what I want, which is that this is symmetrical. I wasn't able to get that symmetricity directly, so I got it indirectly. So what I want next, I have 1 degree of freedom. That degree of freedom may be because this one can go up and down. I want to fully constrain it by taking this distance. So I want a vertical distance defined, a vertical distance from here to here. I want that vertical distance to be 175. So you can see that is defined and fully constrained. So I can close and say, okay. So with that closed, I go home. Now I want to turn this one into a pad. So I choose a pad. It's giving me its normal 110. I want 100 this time, and I want it to be symmetric. And then, okay. Okay, so the next thing I want to do is to do a drawing on the adjacent plane, and I reversed what I've just done. So on the adjacent plane, so I will start with a drawing, and that drawing on the adjacent plane will now be done on the YZ plane. So on the YZ plane, I'm going to make 2 moves. The first move is that I will bring in some important points on the previous geometry. So I choose this. I want to bring the points, this point, this point, this point, and this point. Those points, those are enough. And because of that, I don't really need the pad any longer. Do I need the pad any longer? I don't think I need the pad any longer. So I want the pad to be hidden. So what I want to do now is I want to do a construction line. To do a construction line, I click this toggle. I want to do a construction line here. Hold on. No. I want to do a construction line, and the construction line will start from here to here. You can see that because I have toggled between construction and real lines, that is there. So I want to do a 3-point circle. I want the circle to be on this. I want the center of the arc. I want the center of the arc to be here. And I want the arc to be like this. And I want it to be like this. This time I want to change this down to the normal line. I want to change it to the normal line. So go back, and I want to increase the arc. So, but I want this arc and this line to be tangent. So I'm choosing the tangent, this. Okay, so there's a tangent there. And then after that, I want a line below here. Hold on, no, I want to change this. To change it to a real line. So the distance between the center of this circle and this should be 175. So I want to take a constraint. constraint vertical, and that is from here to the center of the circle. I want 175. So let me push that away. Now, I want a polyline. I'm going up here. And I want to place my M 3 times. Join this one. I'll start again from here. M 3 times. Join this one. Now, so we're going to now apply constraints to make this look like the one we had before. So I'm going to take this and this, and I want them to be tangent. Similarly, this and this, I want a tangent. I want this to be vertical. Undo. That constraint was not properly. That constraint, let me delete that constraint. So I want this and this to be horizontal. And I want this and this to be vertical. Okay. Similarly, I want this and this to be vertical. Okay. Then let's see whether I can move this. So I'm going to use some constraints here. I want the horizontal distance from here to be 10. So take the horizontal distance between this point and this point. I want 10. And I want the same thing here from this point to the center there. I want 10. Okay. So, and now the radius of this, I want a radial constraint there. The radius of this, I want 50. I didn't get that. Not happy with that. I want a radial constraint. 50. What is the problem? I want this and this to be at the same horizontal level. So I'm going to take the horizontal constraint here. That is from this one and this. It's not obeying. So what am I going to do? Let me push this up. Let me remove this. Let me remove this. This is getting a little bit. Let me bring the pad up. Okay, so the pad is there. I want this radius. It is over constraint. So let's see what are the constraints that are not good. So let me remove more constraint and let me remove another constraint. Okay, it's under constraint now. So this will be here, and then this distance from here. The distance between here and center should be 50. Okay, so how many degrees of freedom do I have left? So since this is 50, this and this and this origin should be vertical. Okay, so it's almost fully constrained. I have one more degree of freedom. Where is that degree of freedom? So is the diameter constrained? Let us see. Let's see the radius constraint. 50. There's no need to constrain that. What is still movable? Okay, this is movable. Okay, so that is it. So I want the horizontal distance here. Constrain the horizontal distance from here to here to be 10. So everything is fully constrained now. How much time do we have? Very little time left. So what I'm going to do now is that I'm going to do this one. I'm going to make this in such a way that I can use it to subtract. And what I'm going to do is I'm going to put a box around it. I'm not going to constrain that box. So with that box, I'll close the drawing. So I'm now going to do a pocket, and I'm going to do the pocket through the entire drawing, through all, and it is going to be symmetric. So you see, on what we have done now, we have a symmetric drawing. So what is left is for us to put the two holes that are inside here. So to put the two holes, very easy. We're just going to take the graphics, the sketches, and edit them. So we're going to edit these sketches, edit sketch. So we're going to put a center circle there of radius 65. Okay, close that. Okay, that gives this hole. And then we're going to do the second sketch, edit that sketch. And we're going to choose a circle. Oh, no, that is not the one. Close. We're going to do this one, the one in the pad, edit sketch there. And I'm going to do a center circle, 65. And then we say close. So the drawing is completed, and I can use the shift key and I can show you what we have done, what it looks like. I have only 4 minutes to go. So let me just tell you something. If you go back to the chat, you will see that I've answered most of the questions you asked me. And you will see that if you put more questions there, I will spend 10 to 15 more minutes after the class to answer your questions. The drawing I've done in class, I've also done one in a video clip that is better than what I think may be better than what your Zoom will give you. I will give you the full transcript of the 2 hours lecture in Zoom. So you tell me which one is better, whether the one I did and sent to you by WhatsApp is better than the one that we recorded online while I was doing it. So you tell me which one you prefer. So let me just rush through the rest of my notes where I'm going to give you your homework assignments. Homework. The first homework is that you use the example we gave you from current slides. Just use the example of the crude connecting rod and do this. That is the first one. The second one, you are going to, this looks formidable, but just make an effort. I'm not going to mark this, but I just want to see your effort. So just try your hands on this over the week and let me see what you come up with. And what is good about giving you this to go home as something to practice is that it will raise a lot of questions with you and you will ask useful questions. I will do this for you next week, but I want you to try your hands on it before you come. And this is the sketch that will create that. This is this thing you see here. This is the fundamental sketch that creates it. So you should be able to try and see whether you can do this sketch completely. And I've given you the steps to do the sketch. And then after doing the sketch, you do the padding, and it is this you are going to cut things from to get you to where you are going. The hardest one would be to get this sweep. We call this a 3-dimensional sweep. And it's the first thing is to do a polyline to give you all these drawings. I saw this on the line, but I wasn't happy with the way the guy who did it. So I decided to use Python to do it. So I decided to write a program to do it. And I'm going to give you that macro program, which you can type into your FreeCAD and get this result before next week. And then we can now talk a little bit more on how to use FreeCAD, how to use Python inside FreeCAD. This is the program that will achieve the same thing. And it is just, you can see, there is nothing really about this program. It's just packing vector positions. All those vectors is writing, those are actually points, position points. And it is joining those position points to get that. When something becomes this repetitive, I don't have the patience to start doing it manually. I would rather write a program. You can create this program, polyline manually, the way some do it on the web. Type this macro and see the elegant way to achieve it, which is superior to what they are doing there. So I showed you how to create a macro. You come to FreeCAD, you click the macro and you choose macros there. And then you now, after that, you execute the macro, a wire is created for you. This wire is created. That's the end for today. Please still go to the chat room. Read my responses to the chats, your questions you have asked before, and bring new questions. I will spend 10 to 15 minutes after the class answering those questions. And remember, all the people asking questions, we are recording everything. We are recording all your activities in this class, and we are going to award grades for participating. So have a nice week. Goodbye.